Hi, in this tutorial I'm gonna show how to train a multi-label classification model using SentiSight.ai image recognition platform. I'm gonna skip some parts that I have already covered in other videos. So let's start by uploading some images. You have three options to upload images. Upload images by selecting themselves, upload a whole folder with images, and upload a zip archive with images. In this tutorial, I'm gonna use the second option. So just select the folder you would like to upload and click Upload. You can optionally label the images during upload. However, I'm gonna skip this step because I have image labels in a separate file. After you uploaded the images, you can either label them using the panel on the left, or you can upload the image labels from a file using this button. The file format for image labels is quite simple. You have the image file name in the first column and the image labels in all other columns. In my case, I have 2 image labels per file. However, you can have any number of image labels per file. So to upload the image labels, you click Upload Labels, Upload Classification Labels, and then select the image labels from your PC. After you uploaded and labeled your images, you can start training. Just click Train, Multilabel Classification. Here you can set the model name and the training time. Notice that each label must have at least 20 images labeled with it. Otherwise, it will be excluded from the training, as this one. You can optionally exclude some of the labels from the training by checking these checkboxes. If you're an advanced user, you can set a lot of advanced parameters. Otherwise, just click Start Training. Here you can track the training progress. After the model is trained, you can click View Training Statistics button to see detailed evaluation of model's performance. As before, the evaluation is grouped into train and validation sets. You can find out the definition of each performance statistic by clicking on it. Also, you can click Show Predictions button to see the actual predictions on images on either train or validation set. The difference between a single label and a multi-label classification is that in multi-label classification, we have a score threshold for each predicted label. If the label prediction is above this threshold, it is considered as positive prediction. Otherwise, it would be considered as a negative prediction. As before, you can filter either only correct or incorrect predictions. A prediction is considered as incorrect if at least one label is predicted wrongly or not predicted at all in the picture. In the basic view, you can only see the predictions that are above the threshold, while in the advanced view, you can also see the predictions that are below the threshold. Notice that we have 2 different colors for the predicted labels. If the predicted label is among the ground truth labels of the picture, then it is colored in green. However, if the predicted label is not among the ground truth labels of the picture, then it is colored in red. Remember that you can find the ground truth labels belonging to the picture on the lower left corner here. When the predicted label is above the threshold, and it's also among the ground truth labels of the picture, it is considered to be correct. When the predicted label is below the threshold, and it's not among the ground truth labels of the picture, it is also considered to be correct. In other words, all green predictions above the threshold and all red predictions below the threshold are correct ones. However, all green predictions below the threshold and all red predictions above the threshold are incorrect ones. Now you may wonder, where do all the thresholds come from? Actually, we have optimized the thresholds so that we maximize the model's performance on the train set. If you're not happy with the optimized values, you can set the threshold values yourself. For this, you need to go back to the model statistics page and make sure that the advanced view is turned on. Here you can see precision recall curve. This curve shows the trade-off between precision and recall at different score thresholds. You can hover the mouse over the curve to see precision, recall, and F1 values at a particular score threshold. By default, we show precision recall, which is micro-averaged over all classes. However, you can switch to some particular class if you like. The intersection between the dashed red line and the precision recall curve, which is denoted by the blue line, corresponds to the optimized score threshold. If you would like to change this score threshold, you can uncheck Use Optimized Score Thresholds box, and then you can enter the new score threshold either into this box, or you can just click anywhere on the precision recall curve to set the new threshold. After this, wait a couple of seconds until performance statistics is recalculated with the new score threshold. Notice that the new score threshold that we set is automatically set both for train and validation sets. Also, if you click Show Predictions button, you can see that the vertical black line corresponds to the new score threshold that we have just set. When choosing the score thresholds, you want to have as high precision and as high recall as possible. So you would like to choose points that are as close as possible to the upper right corner. So good candidates include this point, this, and this one. You can choose yourself whether you want to refer to validation precision recall curve on the train precision recall curve. We have chosen train precision recall curve when optimizing score thresholds because we found that it gives better results when testing. If you would like to set a uniform threshold for all classes, you can click All Classes and then select the score threshold and click Set. You will get a confirmation window whether you really want to set thresholds for all classes. Then just click Yes. Then if you click Show Predictions button, you will see that the score threshold for all classes is the same. Another new feature that we have added both for single label and multi-label classification is an option to choose whether to use the best model or the last model. To understand what I mean, let's have a look into the learning curves. Usually, the cross-entropy loss decreases both for the train set, which is denoted by the blue line, and the validation set, which is denoted by the green line. However, if you look into a model that I have trained earlier, you will see that sometimes the cross-entropy loss continues to decrease for the train set, which is denoted by the blue line, but starts slightly increasing for the validation set, which is denoted by the green line. That happens if the model is overtrained. During each training, we save two models. The first one, the so-called best model, is the one that has lowest cross-entropy loss on the validation set, and it is denoted by the dashed red line. The other one, the so-called last model, is always saved after the last iteration of the training. If you look into the previous example that I showed, you will see that both of these models are exactly the same. In case the two saved models are different, we usually recommend using the best model. However, if your validation set is small and lacks diversity, you might consider using the last model instead, because the best model cannot be selected reliably. Finally, you can make new predictions using your model by clicking Make a New Prediction button. Just select the images you would like to predict. As before, here you have options whether to use the best model or the last model, and whether to use custom or optimized thresholds. The predictions are visualized here, but they can also be downloaded as images grouped by predicted label, as a JSON file, or as a CSV file similar to the one that I showed in the beginning. Don't forget that you can also use REST API to make the predictions. For more information about this, you can refer to our user guide here. So this is all I wanted to share about training a multi-label classification model using SentiSight.ai image recognition platform. I would also like to thank our partners at Concology.be for kindly sharing the images used in this tutorial. You can download those images using a link below. Thanks for watching.